The quantum world, a world of possibilities. Imagine looking at a glass of water. On the surface, it appears continuous and smooth, but zoom in far enough, past the droplets, molecules, and atoms, and you'll find that matter is not smooth at all. Instead, it consists of tiny particles that behave in ways unlike anything we experience in our macroscopic world. In the quantum realm, particles such as electrons and photons, light particles, don't behave like tiny billiard balls. Instead, they act more like waves. These waves represent probabilities, meaning that particles don't have definite locations or speeds. Instead, they exist in a state of superposition, a blend of all possible outcomes, until they are measured. This idea is central to quantum mechanics. Let's see the key principles of quantum physics. First, we have wave-particle duality. Particles like electrons and photons can act as both particles and waves, depending on how we observe them. For instance, light can behave like a beam of particles, photons, in some experiments, and like a wave in others, such as when it creates interference patterns. Then, superposition. In the quantum world, particles can exist in multiple states at once. For example, an electron in an atom can be in multiple energy levels simultaneously. When measured, it chooses one state, and this collapse of possibilities is a cornerstone of quantum mechanics. Now, entanglement. Imagine two particles that are entangled, meaning they are deeply connected even if separated by vast distances. A change in the state of one particle instantly affects the other, no matter how far apart they are. Albert Einstein famously called this phenomenon spooky action at a distance and uncertainty principle. Proposed by Werner Heisenberg, this principle states that certain properties of a particle, like its position and momentum, cannot both be known exactly at the same time. The more precisely you measure one property, the less precisely you can know the other. Quantization. Energy, like matter, comes in tiny packets or quanta. This explains why electrons orbit atoms in specific energy levels instead of a continuous range.